So we got through the first problem in class together. Depending on which class you were in, we went through. The answer was in the midpoint. Uh, it was 360, and so we used all the midpoints. But you can do the left and the right as well. If you're interested in checking out, if you're doing left, the shortcuts would be to use the left lengths, not using the last one. And if you were doing the right, you would use the right lengths, and you get a bigger answer if you use the right. The midpoint somewhere in the middle. It's not the average. If you add those up, it is not the average. Okay, on to this problem. Let's go ahead and work on reading it. The table shows the velocity of the speed of boat at 15-minute intervals. For the first hour, use a right-hand Riemann sum to find the distance the boat traveled. So they don't tell you how many intervals, so just use the intervals that they give you as widths. And so all of these are 15-minute intervals, which is, if you notice here, this is in miles per hour and this is in minutes. So I'm going to change this. These are quarter hours. So if you change that, becomes 0.25, 0.5, 0.75, and 1. So that we have our table. If all we have to do is find a right Riemann sum. So my widths are 0.25 hours. Again, we want this to be hours because we're finding area, and it's time in hours times miles per hour. It gives us miles. So I'm going to do a right Riemann sum, and so all I'm going to do is use 120 plus 90 plus 75 plus 40, not using the 0. Okay, so you can add those up, divide them by 4, whatever you do with your simplifying. Multiply by 0.25, however you want to do it. So you get 81.25 miles in an hour. Well, if you look at your speeds, you're going from 0 to 120 over that time. This at least is a reasonable answer. If we did the same problem using a right Riemann or a left Riemann sum, again, nothing changes with the width. It's still a fourth of an hour, but we would start out with 0. We use 0, 40, 75, and 90, and not use the 120 this time. So that's going to be definitely less. So you get 51.25 miles. And that was not part of your assignment, but so you can compare if you're still confused about the left and the right. If they asked you to do midpoint on this, you would have to only be able to do 2 intervals. You could use the 15 and the 45 and do an interval with midpoint, but not very good usage there. Okay, and I'm going to start but not finish question 3 here. They bought a rocket and took it outside to set it off. She recorded the velocity in 5-second intervals. They don't tell you how many intervals to use, so you got to count them up. 1, 2, 3, 4, 5, 6, 7, 8, which means we have 9 numbers. So the width is 5 seconds. So on both left and right, you're going to have a 5 out here, and then your heights are just going to vary. It says use the left hand, so this side would be our answer, but you could do either one. If you were going to do midpoint here, you'd have to use bigger intervals. You'd have to have it go from 0 to 10, 10 to 20, 20 to 30, 30 to 40. And so that would give you midpoints. I can show you that one, even though that's not part of the assignment. That's just a little review of the midpoint. So if we're doing midpoint, we need the midpoint value. So we need this one, which means we're going from 0 to 10, 10 to 20, 20 to 30, 30 to 40. Anytime you get yourself confused, just make a little picture. Say, okay, I need the 5, the 15, the 25, and the 35. So really, it's not any more complicated. The trick here, to be careful is your rectangle is wider if you're doing midpoint. So the base, that's why the picture helps. The base is 10 instead of 5, and then you use those 4 heights. So these are all part of the exhaustion method. We will learn a way to be more exact, but for right now we are exhausting.